Now, question of the day. A block of mass 4 kg is pressed against the wall by a force of 80 Newton as shown in figure. Determine the value of frictional force and block acceleration. Okay, our motto: determine frictional force and acceleration of the block. Okay, mu s and mu k given. Mu s means coefficient of static friction, and mu k means coefficient of kinetic friction. So first of all, make free body diagram of that block. Mg always work on downward. Before making block diagram, component of 80 Newton with this one is horizontal is how much? 37 degree. So component of 80 Newton is along x-axis and y-axis is how much? That is 37. So you can say that here 80, here 80 cos 37 and here 80 sin 37. Cos 37 is 0.8, so 80 into 0.8, that is how much? That is 64 Newton, and that value is how much? 80 into 0.6, so that is 48 Newton. Okay, clear? It means, what is the meaning of that one? In this direction force 1848 Newton, okay, and in this direction force, that is how much? 64 Newton. Okay, clear? Weight of mg always work on downward direction, so 4 into g, like that one. Clear? And block also, here this is wall, so wall also apply, if press 64 Newton on the Newton force apply on the 4 kg block, then wall also apply force, normal force N1 against this block. Okay, always perpendicular to surface. Now, according to question, the whole system in equilibrium. Okay, no. So question is not say equilibrium or not. Okay, but here wall, so this block is not moving corresponding to x-axis, so you can say that net force in x direction is 0. So N1 this will be equal to how much? 64 Newton. Clear? After that here 48 Newton and here 4g. For simplicity point of view, g have taken 10 meter per second square. Okay, so okay, and also determine if N1 is, we got 64 Newton, so F static friction, or you can say that limiting friction and kinetic friction, maximum value of static friction, that is limiting friction is how much? Mu s into N1. Mu s is how much? 0.2. N1 is 64. Okay, that is how much? So that value is written as, that is 12.8. Okay, Newton. And what about kinetic friction? Kinetic friction is mu k into N1. So mu k is how much? 0.15. N1 is 64. Okay, so multiplication of these two, 64 into 0.15, that is how much? 9.4 newtons. Clear? Okay. After that, if you see very carefully, now here 48 Newton and here 4g. If g taken, if you have Kelsey, then we have taken g this equal to 9.8. If you can without Kelsey, you can take 10 meter per second. Okay, so if you taken 9.8 meter per second, then that is how much? 4 into 9.8, that is how much? 4 into 9.8, that is how much? 39.2 Newton, downward direction. Now look, applied force in which direction? 48 Which one is higher? This one minus this one, that is 48 minus that is 8.8. Net force in this block in which direction? Y direction. So make again free Y diagram. Here net force 48 minus 39.2, that is how much? 8.2, sorry 8.8 Newton. Okay, and here normal force, here that is 64 Newton, and here N1. Okay, clear? Net force corresponding in Y direction is how much? 8.8 in upward direction. So frictional force developed in opposite direction, in this direction. Okay, that is how much? Check, that is 8.8 Newton. So this one is greater than 12.8? No. So it means block is not moving because of static friction. Limiting value is 12.8. This block is moving only if applied force, this is applied force. Applied force is greater than limiting value, then acceleration is not zero. But here F is less than FL, it means A is 0. Clear? In that case, so you can say that A is not 0. A is 0. Why? Because of limiting value is greater than applied force. Applied force is how much? 8.8. So it means F minus frictional divided by mass, and that value is 0. So F this be equal to small f. It means capital F is how much? 8.8 Newton. So frictional force is 8.8 Newton. Okay, clear? So frictional force that is how much? 8.8 Newton. Okay, and whatever oscillation of the block is 0. Why this block is not moving? Because of that value, applied force is not greater than limiting value. Okay, here limiting frictional value is greater than applied force is 8.8. So this block is not moving. So which option is correct option? So 8.8 Newton frictional force and oscillation of the block is 0. So which option we more closer? That is A. A option is correct option. If you've taken 10, then we got first option. Okay, but if I have taken 9.8, so it is closer to that one. Okay.